Okay, mark it as equation number star. Okay, you defined fn, right? So mark it as equation number star, and you are going to complete the first part of this proof. Okay, so let me turn the next page. From this you can say, if there is a finite disjoint subcollection of f that covers E, if you are saying that if there is here you are having a finite collection. Okay, if you get this finite collection covers if there is a finite disjoint subcollection of f that covers E, means you proved the result, you proved it. Okay, the proof is complete. That is how you have to write. If there is a finite disjoint collection of f and that is covering E, means that is what you have to prove in the statement, right? So you proved it, the proof is complete. Otherwise part is little bit lengthy. You have to keep something in your mind. Okay, otherwise we inductively choose a disjoint countable subcollection. We are choosing a disjoint countable subcollection, that is this. In the above you are having finite disjoint subcollection, that is why k is equal to 1 to n. Okay, now you are considering countable disjoint subcollection. Okay, there is a little bit difference between finite collection and countable collection. I have to refer it. Okay, till now I am also not aware of it. Just now the doubt arises in my mind. Okay, so I will look it. I will refer it in future. Okay, we inductively choose a. Now you are choosing a disjoint countable subcollection. Just before what you deal with, you deal with a finite subcollection, disjoint finite subcollection. Okay, if that disjoint finite subcollection covers E, means the proof, you proved the result. Otherwise otherwise you are choosing what? Countable disjoint subcollection, that is this. Okay, of script f, which have the following property, that countable disjoint subcollection you are choosing, no, that should have a property. The property is this. Okay, E difference union k equal to 1 to n ik. This will be, you will get a value for this, right? You are subtracting this from E and you will get a value. That value will be subset of this for all n. That value will be subset of what? Union k equal to, here till n you have, till n you are subtracting. So after n what you have? You will have n plus 1, n plus 2, n plus 3, right? So that is what you are having here. This value will be subset of k equal to n plus 1 to infinitum 5 star ik for all n. Now let us write about what is I, what is 5 star I here. Okay, so where I is a closed bounded interval, you know from the beginning, you know this from the statement itself. I is a closed bounded interval, right? You are writing it again and then you are writing 5 star I denote the closed interval. Here 5 star I you are having, right? You are writing about it. 5 star I denote the closed interval. This is also what? The closed interval, but it having some property. Let's see that has the same midpoint as I. In 5 star I and all, imagine you are having I and you are having 5 star I. In both 5 star I and I, you will have the same midpoint. But in 5 star I, for 5 star I, the length of the interval is 5 times. Okay, 5 times its length. Length will be different. Length is 5 times its length. That is what they are writing. But the midpoint of 5 star I and I will be equal. Is that clear? That is what they are saying. You know that 5 star I means 5 into I. There is a difference between I and 5 into I, right? There will be 5 star I will be lengthier when comparing with I. That we know, right? So that is what they are writing like this. 5 star I denotes the closed interval that has the same midpoint as I. Midpoint will be same, but the length will be different, and 5 times its length. Same midpoint as I and 5 times its length. Is that clear? Okay, now you are taking an interval I1 from F. You know that from you are having collection of intervals in this F. So from this F you are taking one interval, that is I1. Suppose n is a natural number. You are having, if n is a natural number and a finite disjoint subcollection, this of F has been chosen. Now what you are doing is, after taking an interval I1, you are taking a natural number, that is n, okay, and a disjoint subcollection. You are taking this collection also, finite disjoint subcollection of F also. You are choosing these two things. Now we are writing, since E difference union is not equal to empty, okay, E difference this will be not equal to empty, that is from the set E, if you subtract this, you are not going to get empty, you will get what, some values, okay. So that is what you are writing, since E difference union k equal to 1 to n, ik not equal to empty, the collection Fn defined in star is also non-empty. If this is not equal to empty, means here you have defined Fn equal to something, right? This is also not equal to empty. That is what you are writing there, okay. If this is empty, this is empty, this is not equal to empty, I'm so sorry, okay, this is not equal to empty. If this is not equal to empty, means the collection here having Fn, right, that Fn, in Fn also this value is not equal to empty. That is what they are saying. Moreover, the supremum Sn, now you are introducing some other thing, that is Sn. Sn is supremum of the interval, here you are denoting it as Sn, okay. The supremum Sn of the length of the intervals in Fn, that is you are having intervals in Fn and you will get length of that intervals. From the length of the intervals you are taking a supremum value. The supremum value of the length is denoted as Sn. The supremum Sn of the length of the intervals in Fn is finite. The supremum of the length of the intervals is what? Finite. Why it is finite? That is what here you are having. Since measure of O is an upper bound for these lengths. Okay. Measure of O is what? The upper bound of these lengths. That is why Sn is what? Finite. That is what you are writing here. Now you are choosing another, by choosing an interval I1 you are writing all these things, and now you are going to choose an interval In plus 1. This interval also you are choosing from, Fn, okay. That must be noted. So here I1 is an interval from F you are choosing. After writing these, after writing about supremum and after writing after saying if E difference union this is not equal to empty, Fn is also non-empty. So if after saying all these things, you are taking an interval In plus 1 from where? Fn, okay, for which with this property you are choosing this interval In plus 1. Choose In plus 1 to be an interval in Fn for which length of this In plus 1 will be greater than Sn by 2. Greater than the length of the supremum value of the length of the intervals divided by 2. This value will be greater than this. That is how you are choosing this interval In plus 1 from Fn. Okay. This inductively defines Ik k equal to 1 to infinitive a countable disjoint collection of F such that for, okay, this inductively defines this Ik k equal to 1 to infinitive. This is what? A countable disjoint collection of F. The first line you have wrote, right? You are again writing that. No big deal. No difficulties, right? This inductively defines this a countable disjoint subcollection of F such that for each n you are writing like this. In plus 1 will be greater than, in the place of Sn, now you are putting in, okay? Okay? In the because this Sn is the supremum value of the length of the intervals till in. In intervals, for in intervals you are writing I1, I2 till in intervals you are writing, no. So that is why now in the place of Sn here you are writing L of I. Okay. Is that clear? I think so. In the place of Sn you are writing L of I now. Okay, L of in plus 1 greater than L of I by 2 if I belongs to F. This I belongs to, you know that interval belongs to F, and I intersection this value is equal to empty. Okay. When you find the intersection of I and ik, you will get empty. No common values present here. That is how you are taking. Now from equation 1, where you have equation 1? Let me see that. Oh yeah, here you are having equation 1. No, on the first page, beginning of the proof, you are having equation 1. You are using here, from that equation you will get this. L of ik converges to 0. You will get that. In between I skipped so many steps, okay. If we write all those steps, we feel difficult to learn it. I feel difficult to learn it, okay. That is the main thing. That is why I neglect some of the steps to avoid confusions. Also we have this also. Where you have this, I will show you. You are having this, right? Just copy down there. From this you are going to bring the answer. From that you are going to prove it. Write it. You are taking outer measure m star of this value less than a subset, no? So less than or equal to m star of this value. Is that clear? Now less than or equal to, bring phi this side so that you will get this. Union becomes summation, right? Summation k is equal to n plus 1 to infinity y, m star of ik. You are writing this by countable. There is a proposition, no? By using this proposition you are writing like this. Union is becoming summation, right? These changes are happening from that proposition. Okay. This can be written as phi is equal to summation k is equal to n plus 1 to infinity. In the place of m star I, you can m star of ik, you can put L of ik. Okay. Here by the definition, L of ik you are putting. Now summation k is equal to n plus 1 to infinity L of ik. That value will be less than epsilon by phi. That is what the step you write in between. Okay. This is what I skipped. Okay, when taking notes I skipped that step. Now only I got some knowledge in this Vitali covering lemma. When writing this I felt very confused and I thought about how I am going to learn these theorems. But now I am okay and I feel like I can also learn this lemma, Vitali covering lemma, right? I can also, now only I got confidence to learn this lemma. Okay. So I hope you can also you are also feeling the same. If you are feeling that, then I will be happy. Okay. So here in the place of this you are putting less than epsilon by 5. Okay. In the bracket you can write like this. Since this is less than epsilon by 5, that's enough. If you felt like studying, then you can learn that extra steps also. I will show. If you look at my notes, you feel very confused, no? That is why by seeing this note we cannot study, because it is very confusing and okay, stress will be increased. That is what the only thing happen if we learn using this note. That is why I separately write like that. Okay, here you can see that step and they are marking it as equation number 5, no? Look at the above steps. You can add this also in between. Okay. So here the place of that you are putting epsilon by 5. From this you will get less than epsilon. So finally you proved Vitali covering lemma, right? So in both cases the lemma holds. The lemma is true. Thank you.